Okay, what we're doing is we're doing peer teaching, and I'm going to facilitate that at each group. And so we pick their groups, and on the Google Classroom, I posted the packet, and it's from a book. It's called Acids, Bases, and pHs. Now we have Alan is of course in China, but we have 2 players that are quarantined, and so you want to, if you can't come and get the packet, you'll have to print that packet off of Google Classroom. And what I'm going to do is I chose one of the groups to be videotaped, so you at least hear what they're saying. I know you can't interact with them, but you can actually watch what they're doing each day and feel like at least maybe you see what they're doing. But ultimately, it's your responsibility to learn this material. And I will, when they get done next week, I'll have a review day. We'll review everything that they learn, and then we'll have a test next week, probably on Tuesday. Okay? So I'm gonna take you over to another desk. Oh, you're videoing? Oh, it's everything. Oh, I thought it was just videoing the back.
Okay, chapter 6.
How about that? Okay, now I gotta figure that out. Let me get a stand.
Oh,
I thought it was videoing. All right, I gotta get something to put you up on top of. Hold on.
Did we just turn one set of the questions
Yeah.
like our best friend?
Uh-huh. Gotta get you a little high chair for the video. Okay, so here are the people that you're going to be listening to for the next few days.
Wait, are we actually only one of us? What's up, Alan?
And Jeb.
Yes.
Oh, that's true. So glad y'all could be with us.
And let me get a book.
Only one of us has to write it down. Like we all have to do it, but we only have to turn in, right? Isn't that right?
Yeah, I remember something.
Okay, so I just you want me to be the secretary?
Oh wait, so only one person has to turn in the questions?
Yes, uh-huh. Isn't that better? Okay, just feel free to talk and just forget there's a video there.
Okay.
Okay.
Okay. So, and if it gets too much, then we can like split them up and then I'll copy them down or something. But I think we just start all together for now.
I'll just write.
Everybody read a paragraph or something?
Yeah.
Sound good?
Caroline, if you want, the 3 of us can read. And then you
Or, yeah, we can do that too.
Oh, sure. Well, I'll stop when an answer comes and then we can talk about it. But I can. Yeah.
So we'll just read, okay. Want to start?
Sure. Do you?
So each read a paragraph.
Okay. So should I read the one at the top of the page?
I think so.
Okay. Acids are very important substances. They cause lemon city sours, digest food in the stomach, and sometimes cause heartburn. Dissolve rocks to make fertilizer, dissolve your tooth enamel to form cavities, and clean those deposits to get property. Acids are essential industrial chemicals. In fact, the chemical in first place in terms of the amount manufactured in the United States is sulfuric acid. 80 billion pounds of this material are used every year in the manufacturing of fertilizers, detergents, plastics, pharmaceuticals, storage, batteries, and metals. The acid-based properties of substances also can be used to make interesting novelties, such as the foaming chewing gum described on page 48. In this chapter, we will consider the most important properties of acids and their opposites, the bases.
Objective to learn about 2 models of acids and bases and the relationship of conjugate acid-base pairs.
So it loses a hydrogen, and
Never mind. Actually,
The first question is, just so that we're all on the lookout, what are some physical properties that historically led chemists to classify various substances? It's gonna be right here, but just go ahead and read.
oh wait, it is on. Sorry. Acids were first recognized as substances that taste sour. Vinegar tastes sour because it is a dilute solution of acetic acid, citric acid.
You only have to do one.
Citric acid is
Oh, I'm
responsible.
just taking notes.
Okay, all right.
Wait, do we have a test on this or will it just be the exam?
What now?
So will we have a test on this or will it just be
Yes.
on the exam?
No, you have a test on it. So it, right now, it's either Tuesday or Wednesday of next week.
Oh, this is gonna make that. Tuesday or Wednesday next week.
Next Tuesday.
We're likely not gonna have a review day altogether, so we're learning this as a group.
Alright, I'm sure there's a review day, so- Mike, okay, it's okay.
Acids were, sorry. Citric acid is responsible for the sour taste of a lemon. Bases, sometimes called alkalis, are characterized by their bitter taste and slippery feel. Most hand soaps and commercial preparations for unclogging drains are highly basic. The first person to recognize the essential nature of acids and bases was Sventi Arrhenius? In the on the basis of his experiments with electrolytes, whereas bases produce hydroxide ions. Where do you?
So I think we can probably,
What are some of the physical properties that historically lend? Oh, okay.
so physical would be like
Sour.
so acids, so I should say,
Wait, Mr. Feeney?
It's accepting the or no.
Is that
The acid, yeah. Acid is bitter.
acids are sour.
Oh, yeah. Bases are bitter.
that really stands on the line?
Don't question it, Tim.
Acids taste
Should
sour.
I be writing this stuff down
Believe it,
too?
Tim.
You don't have to.
This is just,
The only way I can remember stuff.
and if we wanna like, we can like rotate the right answers if this helps y'all learn more, so. Acids taste sour.
Bases are bitter.
Bitter. It also says bases are usually very slippery.
Bitter
That's what it is.
and
I tell you what,
Mr.
yeah, let's see. You want to just do it?
So in this circumstance, sodium bicarbonate would be a base.
Hey, would you rather just do the odds instead of all of them?
oh,
I thought that's what we were.
Well, yeah, all of them, yeah. Just odds. We're just doing odds. I'm
Okay.
sorry. But you have to do all of them within it, though. We're just doing odds, so that's fine. So if there are 6 in us, you have to still do all 6.
Well, that's good.
okay, so I have acids taste sour, bases are bitter and slippery. Anything else? Physical properties. Acids, would I say like acids produce hydrogen or?
Oh, acid. Oh, I skipped so much.
What is that?
The first person recognizes
Physical
the nature of
property.
acids and bases.
Hydrogen
That is physical.
ions.
Yeah, I think I should say that, right?
That's a physical property.
Acids
Bases produce.
produce
Okay.
hydrogen ions.
What
In
definition
an
of that?
aqueous solution.
Whose definition
So
of that?
that's that's when they're dissolved.
And Arrhenius was given credit for even discovering that there were ions, and his definition said, if you, in a solution, if you contain hydrogen ions, you're gonna be an acid. And that's the simplest definition we have, but then you're gonna read about another definition later that is different.
Did all the odds of the next set.
Are we doing that active line question?
Hydroxide ions, bases.
We're not doing the additional questions either, so.
Just where it says questions and problems.
So when they're dissolved in water, that's what they
So
produce.
when they dissolve in water, acids produce hydrogen, bases produce
Yes.
hydroxide. Okay, so we did one.
Right,
Number three, according to the Johnston law.
We're not there yet.
I know, but just like so that we come across it. An acid is a blank donor and a base is a protein.
right, so for example, when hydrogen chloride gas is dissolved in
Okay.
water,
Yeah.
each molecule produces ions as follows.
I think he misplaced the blank there.
We haven't gotten there yet.
Again,
Yeah, but
dynamics down.
So what's the flow?
You want to discuss.
This solution is
and then
strong
you ask the
acetate,
question, right?
known as hydrochloric acid. On the other hand, when solid sodium hydroxide is dissolved in water, its ions separate into a solution containing sodium and hydroxide ions. The solution is formed from base.
I can read that. Although the Archimedes concept of acids and bases was a major step forward in understanding acid-base chemistry, the concept is limited because it allows for only one kind of base, the hydroxide ions. A general definition of acids and bases was suggested by the Danish chemist Johannes Bronsted and the English chemist Thomas Lowry. In the Bronsted-Lowry model, an acid is a proton donor and a base is a proton acceptor. Okay, that's
Classified very substances.
so an acid is a
proton donor.
Or whatever they call it.
yes.
You just
So
said
proton donor.
acids have
Do I have to write that one sentence?
bases have hydroxide, but also like the physical properties like
Proton donor.
like
And then the next one is
I don't know what they call it, what they call it, the bases. Slipperiness.
So acids are sour and
I am gonna write this.
anything else besides that?
Produce hydrogen ions.
But it's a physical property, do we want to give chemical properties too?
You don't have to, that's it.
Well, dissolving things.
A proton
What?
donor.
I think I can explain that in a way that might make more sense or might make less sense.
An acid gives up a proton.
But I don't think that's exactly what it means
I'm sure it'll
entirely.
explain it.
Like
Yeah,
non-metal.
it kind of makes sense. It's okay.
Okay.
It's like non-metal metal.
No, it's not like that. It's not like that. Because what I think it means is, so look on this previous page where it's showing the hydrochloric acid and the sodium hydroxide. If those two react, the hydrochloric acid is giving up a positive hydrogen, and I think that's what it means by proton donor. It's giving up a positive ion. I think,
Okay.
and the yeah.
Okay. Okay, so according to the Bronsted-Lowry model, the general revelation that occurs when an acid is dissolved in water can be best represented as an acid HA donating a proton to a water molecule to form a new acid, conjugate acid, and a new base, the conjugate base.
And the proton in this
So-
case, the protons are just the.
They probably do that. That's really.
So,
I'm
okay, wait, I'm gonna say that
That's
this
a lot of paper to print.
That actually might cause it to be HSO4 minus one.
Water's base because it's proton acceptor.
So this is the HA.
Okay, so basically,
HA. So what they call this, they call that the
when an
acid.
acid is dissolved in water,
What do they call
an
this?
acid, which is HA, is donating a proton to the water
After it's donated,
molecule to form a new conjugate acid.
Okay. So I was wrong in
they call it
a hydrogen, a positive hydrogen ion is just a proton.
They call it conjugate acid base pair.
So yeah.
Look at this one.
Oh, okay.
So it's like.
In the next paragraph, it says.
So it's giving up a proton, which is the hydrogen.
Okay, so this model emphasizes the significant role of the polar water molecule pulling the proton from the acid. Note that the conjugate base is everything that remains of the acid molecule after a proton is lost. The conjugate acid is formed when the proton is transferred to the base. A conjugate acid-base pair consists of two substances related to each other by the donating and accepting of a single proton. In the above equation, there are two conjugate acid-base pairs, HA acid and A base, and H2O base and H3O acid. For example, when hydrogen chloride is dissolved in water, it behaves as an acid. In this case, HCl is the acid that loses a hydrogen ion to form chlorine, its conjugate base. On the other hand, water, behaving as a base, gains the hydrogen ion to form H3O, the conjugate acid. How can water act as a base? Remember that the oxygen of the water molecule has two unshared electron pairs, either of which can form covalent bonds with the H ion. When gaseous hydrogen chloride dissolves in water, the following reaction occurs. Note that an H ion is transformed from the HCl molecule to the water molecule to form H3O, which is called the hydronium. Okay,
So,
let's unfold that.
So,
Can I ask you a quick question before we go?
Yes.
The author thinks you know what that means, and I don't think it explains it, so what do you think HA is?
For this one, we said the, when they're like,
yeah.
Why? Why is it, what's the H and what's the A stand for?
The H is the hydrogen ion, which
Yes.
is the proton.
That is correct. That would be this part, right? And that's the, what's this now? That's the cation. And what is this?
That's the S.
It's the other part. If that's the cation, what's this gonna be?
That's the anion.
And what is A? See, that's where the A comes from.
And
See
when
that A, that could be chloride ion, see? It could be chloride ion, it could be a sulfate ion.
and whenever it's referring to donating a proton,
Yes.
that's referring to the hydrogen.
Yes, because in the grid game, what is one proton in the grid game? Atomic number 1. Element, hydrogen. No electrons.
That's really
The proton is a hydrogen ion.
yeah.
See if you remember that, even in your biology class, you need to know.
Yeah.
Okay.
So for number 5, it says, given the general equation illustrating the reaction of the acid HA and water, explain why water is considered a base. Okay, so that's right here, but I don't really know the answer.
So
Because
it's
it's the one using
because it's accepting the proton.
Oxygen of the water molecule has two unshared electron pairs,
It's
either of which can form covalent bonds with the hydrogen ion.
Is that a hydrogen bond or is that a nuclear chemical? This is hard to explain.
That's assuming that when you put in water, it
So
splits
it
up in
accepts
ions.
a,
If it doesn't split
gains
into
in
ions, then Arrhenius.
Yeah, so I think this is a situation where like
It can be a base, in fact,
it's being
kind of
dissolved,
later. Like,
or is it being?
it could be an acid too.
so
Water is a base because it's accepting a hydrogen.
so water
I just
accepts.
so is this the same as an acid being dissolved in water?
Okay, now,
Or is it different?
sometimes you have to be careful about how they do it. The word dissolve, like sugar dissolves in water,
Right.
that is a physical change. Where it is true that when you dissolve HCl, the gas, in water, it not only dissolves, it also ionizes.
Okay, so you're saying CN.
Now, I don't know if I mentioned that, but when it dissolves, it actually will ionize into these ions and these ions. See, sugar will not.
So
So true dissolving is a physical change. This would be a chemical change here.
so this is so is hydronium just HCl being dissolved?
No,
It's
so what
just-
happens is, this water is going to accept that proton. And what's the definition of a proton acceptor? A base. So water's gonna act like a base and accept this and turn into H3O. H2O will take this guy and turn into H3O plus 1 charge. This is like a polyatomic ion called hydronium.
So it's a hydrogen. Or I guess like,
No, I think they would share. I think it would be a covalent.
so oxygen would be holding 3 electrons here?
It would actually has,
Or is it just
Oxygen-
attracting the hydrogen ion?
oxygen has,
It's negative.
oxygen is number 8 on the periodic table, right? Two of the electrons are in the first energy level, they're not available for chemistry. But the other 6 are, that's why I think group 6. Of those 6, one of mine and one of yours will form this covalent bond, one of mine, that leaves 4 more. And they're paired up. So that means I could do this and form a covalent bond, but I'd end up having a +1 charge, like a polyatomic ion.
Got it. And so it would form on with something else pretty quickly.
Now, what's interesting, and you're gonna see this very soon, is, see this guy here? Guess what can happen? Not with this guy, but with another acid, the arrow can go the other way. And then guess what happens? Now, the thing that was a conjugate acid, it's going to go this way and become an acid. And, because it's gonna donate a hydrogen ion. This guy, who used to be called a conjugate base, is going to be a real base, like that. So if the reaction goes this way, you'll see how they, you still have the conjugate acid-base pairs though.
That was 12. Okay, sorry for wasting time.
So for number 7, so I wrote down 6, or 5, I basically wrote down like all this because I just think it makes no sense. So for 7, it says, which of the following do not represent a conjugate acid-base pair? Or those pairs that are not conjugate acid-base pairs, write the correct conjugate.
Take this away,
Okay, so identify, so it says which of the
it'll
following
be found on the other side of the arrow.
A and B are,
So
I think A doesn't,
So they have
because
to-
both are, is that,
A
wait,
is, right, because C on the base.
They have to just differ by 1 hydrogen ion. Is that the
and
period of
Cl
time?
is a,
Species differ by 1.
yeah, that's just,
So that means that would be,
We have an active
A,
yeah.
it would be not B, it would be not C.
is D, what is D? Because is,
Oh, so it would be
So
B.
A is, right?
Because it
yeah, I
says what
think,
should it
I
be.
think A is,
A's the only one that
that's
is.
not. You want us to read the next chapter?
So,
I think,
7, the answer is B, C.
wait, is,
Wait, so we're saying which one is?
it's, which is not a conjugate base, acid base pair. So A is the only one that's not.
Why not B?
Because B, oh wait, no, A's the only one that is.
It's,
Yeah, but why not B? Why is it?
wait, why is,
So
why is A a
A
conjugate base, acid base pair?
Because it differs by 1 hydrogen ion. Or
A single proton,
a single proton.
I think
But the
A
other
is
one-
Oh,
the,
because B is 2 though, right?
well, B,
2 hydrogen.
Yeah, so there's 2 there.
H2SO4 is a base. No, that's an acid. But, wait, which is not a conjugate acid base.
Yeah, so A is, C and D.
A,
B, C, and D are
why
B
is
not
that, wait,
two
so,
protons, right?
in order to be conjugate base, acid base pair, there has to be a acid and base.
because it says,
Cl is a
correct.
base, right? It is?
So it would be, oh, for B,
Because
so
it's 6
correct,
protons
it
on
would be
Is that the definition for?
H.
Hey, very good, very good.
That's not a acid base.
Okay, so B and D would be the
Okay.
answer.
Time to stop.